All right, so you guys ready to review our game from last time? So remember that we made an array of size 52 to hold all of our cards. And then we were practicing sending arrays to methods. That was the point. So we sent the array to the method. Remember, when you send an array to a method, you just put the array name. You don't have to put any square brackets. And it sends in a reference to the array, so it's sending in the actual array address. So when you change it in your method, it's changed back in main. It's called a call by reference. So inside of this method, we had a dual for loop that filled it up with the numbers 1 through 10 4 times. Okay, so it filled up, for the 4 clubs, hearts, spades, and diamonds, it filled up the cards 1 through 10. We didn't care about if there were spades or hearts or diamonds, so we didn't bother with that. And then we filled up the face cards, and we did that for the rest of the array. We filled it with the 10s to represent our face cards. And so the only thing we had to remember is that our aces we stored as a 1. And so when we program it, we'll have to remember that it could be an 11 too. Okay. And then we did this for testing purposes. We printed out our array. Whenever we print out an array, it's always the same. I equals 0, I less than the array.length, and I plus plus. Remember, that's called iterating through your array. And it's to print out all the cards. And we did that to test it, right? So we printed out all of our cards to make sure it filled it right. Which some people did actually have errors here, so it was good that we did that. All right. And then we had, we set this variable when equals 0. And the reason that we put this for loop in, and this code right here, remember that we did this at the end of class, and we did this code to test the statistics of getting a 21 on your first hand. So we put this for loop so that we could run it 10 million times or 10,000 times, and the statistics, the ratio always came out the same. You guys remember what percent of the time you get a 21?
Not 40.
No, not 40. 4%. A little bit, about 4.8%. And if you go and look online, which I did, that is the right percent. So almost 5% of the time, you will get a 21. That's why they pay you out. It's not a big percentage. Not a big time. So we can actually comment out this code now. Remember, if I comment out the for loop here, I need to comment out his ending curly bracket. Because I don't need to run the statistics every single time. But I could leave them there. And so if I do a Control-A, Control-I, that stuff should de-indent now. And I think it's cool code, so I'm going to leave it here. Okay. And that was kind of a cool thing to figure out, what percentage. And note that, running a computer program like that actually, and then doing the math, you get the same answers. So cool. All right. So remember that we dealt out 2 cards. There was a small flaw in our program that you could actually choose the same card. But we said, whatever, that's okay. So remember that we got a random number between 0 and 51. And then we use this as our index inside of our cards. Cards array. In fact, I thought we should program this a little bit cleaner. So you guys want to program it a little bit cleaner? Let's make a card variable and set them equal to this. Oops. We probably should have done this last time. But remember that you can clean up your code after the fact.
Couldn't you just change card 1?
No, because we're using it as the index in our array to choose our card. If we did that, remember that this number gives back a number between 0 and 51.
Well, why can't you just name it differently?
If you wanted this to be card 1, you could program it this way, but we wanted to practice arrays and then go up to 11. But we wanted to practice arrays, so we didn't do it like that. So remember that we're using this number as the index in our array of cards to grab a card out of our array of cards because we're practicing arrays. Okay. And then I can replace this kind of writing with card 1. And it just makes it a little bit easier to read. So notice it's the same code. I'm not changing the code at all. I'm just changing... I'm just changing the syntax so that it could just read a little bit better. So if card 1 is 1 and card 2 is 10, or card 1 is 10 and card 2 is 1. Remember, this is when we're checking to see if we have 21. And that was our statistics code. Okay. All right, so if we get 21, remember that was in our algorithm. That means we win and we end the game. All right, so we had a few lines for stats code. So I just wrote notes to myself that, hey, I used this for the stats code. That's what that guy is, remember? So your code shouldn't have any red errors. Now what was the next step in our game? No, we had to do something else first. We wrote it down in our algorithm. So right now we've done up to this step. Yeah, we need to deal with the computer 2 cards. Check to see if the computer got 21 and then print if he got 21. All right, that's easy because that'll be copy and paste code. Okay, so we can copy this code. We don't want to redeclare those. And then we need to rename these a different name. Because remember, we don't want to overwrite our cards. We want to give the computer his own cards. So we're going to deal out 2 cards to the computer. And actually, I should have left this code up there. Yeah, because remember that we commented out our for loop. We took out that stats code. So anything having to do with stats, remember we did that at the end of class. It doesn't really part of our game, so I commented out all that stats code.
Do you want to take out the printing out of every number too?
You could if you wanted to. I just left that one in there. It would make the font really small. But you guys should be able to read it. So look at your algorithm and it should match up to your algorithm. First you fill the deck with cards. Then you deal yourself 2 cards. You check to see if you got 21. Then you deal the computer 2 cards. And now you want to see if the computer got 21. We're writing this rather procedural-like. So after we deal the computer 2 cards, we want to check to see if the computer has 21. So we can check the computer's cards the same way with the same logic. So we're going to check the computer's cards. And if the computer has 21, we'll say the computer has 21. Computer wins. Right? So same logic that we used before. We know he has 21 if he has an ace, which was represented by a 1 and a 10. Right? You guys should be able to kind of write that code without even looking up here almost. Yes, you should be able to. Okay. So all we're doing is accessing a number in our array. Now there is a flaw in our game. We are reusing cards. The computer could happen to get the same index we did and have the same card as us. So, you know, whenever I think how to solve that problem, I always think of object-oriented design. So that's a little bit beyond the scope of our class. I guess we could make a parallel array. All right. Now you should run your game to see what the computer has dealt out to him. Remember that you can comment in these system out print lines to print out your cards and the computer's cards. So if you want to see the computer's cards, go ahead and print out computer card 1. And go ahead and print out computer card 2. And then test your code. This is a great place to test it. Remember, you add a couple lines and then you test it. And it should deal you 2 cards, and then it deals the computer 2 cards. And if either of you have 21, it should say, hey, I won or he won. Or if your computer's a girl, she won, right? All right. Hey, the computer. Oh, I have 21 and I win. All right. So let me walk around really quick and help you if you have errors. Okay. What is our next step? Our next step was show one of the computer cards. We did that step by default. We're showing 2 at first. If we only wanted to show 1, what would we do? Just comment out one of the system out print lines. Okay, I'm going to leave both up for now while I'm testing. But when I'm done with the game, this will show 1 card, this show 2 cards. Right? Right. Okay. Cool. Our next step was ask the user to hit or stay. If hit, then deal them another card, and then keep going like this. So this is kind of like a loop. Asking them, hey, do you want to hit or stay? Do you want to hit or stay? Do you want to hit or stay? Okay. So you know that's going to be a loop. So here's our step. We will ask the user to hit or stay. So what kind of loop should we use? Do we know how many times the user is going to hit or stay? No, we don't. So we don't want to use a for loop. For loops are for when we know how many times we want to loop. A while loop. Remember, we have a do while, we have a while loop, and we have a for loop. So our choices are, if we don't know how many times, either a do while or a while. Either one would work well here. Now we want to execute this regardless of what the, so a do while would actually almost work the best here. Now if you used a while, it wouldn't be wrong, but I think a do while, because we want it to happen at least one time, a do while kind of says, oh yes, that makes a do while. We want it to happen at least one time. Okay? Because we do want to ask the user at least once whether they want to hit or stay. Okay? So how do we ask the user if they want to hit or stay? You guys should be able to write this code. You do a system out print line. Do you want to hit or stay? How do we get input from a user? Right. We know this. Scanner keyboard, or scanner input, or scanner inside, or scanner whatever. And since we're using the console, we're going to use system.in. Now if we translate this to a GUI, the logic will stay the same, but we'll input it from a text box, or a radio button, or a button that they hit yes. Hit me. Because you could actually take this logic and take this code and make it into a GUI. Okay? Graphical User Interface. That's what GUI stands for. All right. How do we get in the user's input? Keyboard dot. Now we have to decide, okay, how do we want to take in their input? Probably a string. Hit or stay is a string. Even if we say H or S, you can't take in a character, you have to take it in as a string. In fact, we should tell the user what to enter.
I did the whole number thing in yellow tape.
A 1 or a 2 or something?
Yeah, I did one for hit and one.
You could do that too.
And it doesn't have to be a string.
But we want to practice our strings, so we'll put strings there. Yeah, we need to practice our strings. Well, numbers we got down. Strings we got. So you can have them put an H or an S. You can even tell them to put hit or stay. You could have them tell, put hit or stay. It'll work the same way. Okay. So we want to take in that string answer. So we need to store it somewhere. So what if they want to hit, we need to do something. If they want to stay, we don't want to do it. So we're going to make an if statement. This is our decision. If their answer, now can I write something like this? Now note that I'm not getting any red underlines, but this code is wrong.
Oh, because it's making it equal to.
No. It's checking equality, but it's checking equality of the memory addresses. If I want to compare strings, how do you compare strings? Whenever you want to do anything with strings, how do you do anything with strings? How do you do anything with strings? You call a method. Yes, you call a function. You use a method. So whenever you want to do anything with strings in any programming language, strings are, a vital part of any programming language, and there's a million methods for strings in every programming language. Whenever you want to do anything with strings, think, okay, there's a function that's already written for me. Okay? So, hey, it even brings it up. Equals. We can even do equals ignores case, so it doesn't matter if they put a capital H or a lowercase h. That's how you compare strings. So if they say, yes, I want to hit, what do we want to do? I'll let you guys fill in this part. We want to get another random card. And show it to the user. And add it to their sum of cards. Now, we haven't made their sum of cards. We probably should have made their sum of cards. So that's something we need to change up above, but we need to add it to their sum of cards. Now, in this do while loop, when do we want the while loop to stop? If they say hit, do we want the while loop to stop? No. Because they might want to hit again. When do we want the while loop to stop? Yeah, when they say stay. Once you say stay, you're not allowed to hit again. Okay, so that's when we want to leave the loop. So you want to check to see if they, did stay. Check to see if they put their answer as stay. Okay, and you guys could fill in that code too. And then the only other thing that we haven't done up above is we need to make that sum. And we need to make the sum so we can see, what their sum is. So how do we get their sum?
Card 1 plus card 2.
Yeah, card 1 plus card 2.
But then you also want to know what the sum is after they hit multiple times.
You just keep on adding it to the sum. So remember to, set sum equal to card 1 plus card 2. And this will be user sum. I'll just call it sum because I just called his cards. Maybe I should call it user sum. And then I also want computer sum. And computer sum is going to be his card 1 and his card 2. All right. Let's see if you guys can write that part. And once you write that part, you can even show the user sum to them. Say like, hey, your sum is, or the culmination of your cards is, or... Alright. So remember that this code we've already written up above. And this code we already wrote right here. So you should be able to write that part. Alright. Write that part. So get another random card. I saw most people had this. You should know how to get another random card. This is how we got a random card. You get the random index, you index in the array, you get a random card. Okay. A lot of people called it random index 3, which is fine if you redeclare a new variable. They even called this guy card number 3, which is fine. Now note, he'll be card number 4 and card number 5 and card number 6 if you keep hitting. Okay? Yeah, next card. That would be even a better name. Because he's not really just going to be the third card. He's going to be all of them. And you can even call this guy next random index. So remember, it doesn't matter what you name your variable names, but that does read better. Now we want to show it to the user. You should be able to print out a variable. Remember, you're just printing them out. And then we want to add it to the sum of cards. You guys know how to add to a sum. Remember to use the plus equal, and you just plus equal your next card. And voila, that part is done. Oh, I called it user sum. Now we want to do this while loop. And we want to check to see, oh, you know what? I wrote this as wrong. Did you guys see why this is wrong, actually? We should check to see if it's hit. And why should you check to see if it's hit and not stay? Because this while loop, no. In the do while loop, to make this while loop happen again, what's in the parentheses has to be true. If what's in the parentheses is false, you leave the while loop. So if they put stay, we want to leave the while loop. If they put hit, we want to stay in the while loop. So we wanted to listen for the true case. So as long as they're saying, hey, hit, then we stay here. If I did listen for the word stay, I'd have to put a not operator here. While the answer does not equal stay, stay here. But it's always better to listen for the positive and not use the not equal. Now you might have gotten this red underline. Now this has to do with locality of variables. Because we declared answer inside of these curly brackets, when I go outside of those curly brackets, answer is gone. It's called locality of variables. So how could I fix that? How could I say, okay, outside of the curly brackets, I want you to be able to see answer? How do you guys fix that? You guys know? Just declare them outside the curly brackets. Then you can see them outside the curly brackets. So take your declaration, declare him outside the curly brackets, but then still use him where you used him before, and now he can see the word answer outside of the curly brackets. And that's actually something we are supposed to know by the end of this class is locality of variables. So it is good to see why that didn't work. Remember, where you declare variable is where he's seen. If you declare him in between these two curly brackets, he's only seen in between those two curly brackets. And actually, the garbage collector comes and takes him away after those curly brackets. Okay? All right. You should be able to play this now. Now note that you could hit 100 times, 200 times. It's going to let you hit that many times because all we're saying is stay in this loop as the user is entering the word hit. So at a real casino, this probably wouldn't work. So if you wanted it to play a little bit better, you'd want to check for something other than hit. You'd want to also make sure their sum is below 21, below or equal to 21. Because you get some crazy person at the table and they're saying hit me and you're dealing them 200 cards, that doesn't fly at casinos, right? I'm sure someone's tried that before. There are a lot of crazy people in the world. All right. But we could just program it simple at first. So do you want to hit or stay? I say hit. Do you want to hit or stay? Now if I put anything other than hit, it's going to stop.
Well, what if you bust?
That's what I said. We didn't check for that. No, you could. You could check for that. We just aren't.
Could you do two if statements if it equals hit or
Right.
if
You could put an or in here.
I'm thinking of saying,
Or some, or actually it'd be and. Yeah, because you want both of these to be true.
Got it. User total is less than 20. Or
Less than 22 or less than or equal to 21. So if you wanted it to play a little bit better, you could put this little and statement in. It's good if you thought of that. Because you only want this for loop to keep going and keep dealing them cards while your sum is less than 21. Or actually less than 22 because it's less than or equal to 21.
if you put the user sum in your if statement up in the do loop,
Oh, right here?
Yeah, could you put it right there? Could we put that right there?
You could, but it'll still go in that loop. If they write the word hit, it'll still keep, it won't actually hit them, but it'll keep going.
Oh. So you want it to stop if it's...
Yeah, so you don't want them, even if they put the word hit, you don't want this loop, you want the loop to stop when they, it's less, or greater than. But good thinking, you know, good that you're thinking. Good, we're figuring it out. I hear I'm figuring it out. Good. Good. All right, awesome. Now it would be nice if you printed out actually their sum, not just the next card. Unless you're keeping the sum in your head, right? Your sum or your total. It'd be nice if you printed it out for the user, so, you know, make it easy on them. Make it hard for them. We're the computer. We want them to lose. Well, this isn't, you print out the card. You have to print out the card. But you don't have to print out the total. All right. So if I put hit, and now it tells me my total is 16. So now I can make a little bit better decision if I want to hit or not. I'll say yes, hit. If you look at your statistics, oh.
you want to put that printout statement below the next card plus user sum.
No, but it got me out of my loop. I did something wrong. Pretty sure we did it right.
Well, how much was your total?
It said it was 16. My total is 19.
I'm getting that problem too. I can't get my fourth card to add to my sum of. But I think the user sum is less than 22, so
Yeah, I know.
it ends.
Oh, duh. I thought backwards. Wait, no. This would be true. That's right. Because we want that to be true to go again. And when that's false,
Because isn't it just a while true? And your true statement must be if
they put the word hit and their sum is less than or equal to 21.
Mine a little bit differently than yours. There's instead of putting it like that, I just put like two more ifs.
Oh, yeah, that's smart. Good job, Douglas, actually. So Douglas checked to see if they got 21 right after they got dealt that card, which is a good check. So he checked it right here. You know, if the user gets 21, the user should win, right? Good. So he enhanced our algorithm. We didn't have that as part of our algorithm, but that's good. And then he also checked if it was greater than 21, then he busted. So he put another couple lines in here.
So another if statement?
Mhm.
In the if statement?
Oh, no, this if statement's 1, and this will be a second if statement. If the user sum is greater than 21, then they bust and lose. So he enhanced that. And notice he put it right inside of that loop, and you can do that.
You put it so you have your if loop and make another one inside of
If
it?
statement, not if loop. And it's good. You could put it right here, or you could put it outside actually too. But-
Is it all recorded at the top? It's staying above. It's always like that.
Yeah.
So I did all that. Let me see. It says unreachable code right here. Which I don't get.
Oh, because you put while true, it's staying there forever.
So then I have to change this.
Yeah. So you have to change that to while you want that loop to happen. We want the loop to happen if the user typed in hit and the user sums less than 21. Less than or equal to 21, so less than 22. What's weird is I got a 15. I said I wanted to hit. It gave me a 10, and then told me my total was 19.
I'm getting that problem too. Like, it's not adding up. My numbers are not adding up right. My string isn't working. It's literally just the string. It doesn't want to. It's just red, and I don't know how to fix it.
Rand index.
I don't know the code.
Yeah, that's really odd. It like kept the 4.
If I hit twice, it doesn't keep the first hit.
No, but this 4 should have been added, and this should be 19. And then when they added the 10, this should be 29.
Do you return after you win or bust? You get out of the loop?
Not down here.
Well, like,
Oh, I mean, you could, yes, I would.
put return in the if statement?
Because that would end your game. Whenever you do a return inside of main, it ends main. Oh, I see why. That was pretty good. There we go. All right, so if yours was doing the same as mine, just make sure you print it out after you add the next card. Duh. Add the next card and then print them out. All right. If you got this part working, excellent. This is a big part of our program. So let's see, your homework is to get the rest of this working. Or at least attempt to get the rest of this working. You guys have the algorithm. Do you like how we're doing? Okay, fine. I'll just say I'm counting it as an extra credit assignment. But I still want everybody to attempt it. That's why I said homework at first, okay? So still attempt to get it the rest of the way working. And then we'll go over the code, because I don't want to spend more, you know, we still need to review and things, but actually I have a student over here, Alejandro, already got his working. He took the initiative, and he's turning into a really awesome programmer. Got an A in the class. He got the rest of his working. Okay, so if you are a computer science major or an engineering major, you need to start, you know, saying, hey, I want to do this. The more you do it, the easier it gets. So try to do this at home, okay? And you can still ask me questions. But we'll count it as an extra credit one, okay?